Hi, YouTubers. I've been having a problem. This is about 7 years old. It used to work perfectly, and I'm not sure uh, why it has issues now with water condensation. I tried to Google everything online, and I couldn't find anything. So basically, I have water puddles, very messy. I've tried to vacuum clean it out, suck it out, but I couldn't seem to. Even I even have a long cloth and a pipe that goes all the way into the garden. So what I did was I didn't show you the video how I open it up, but I will show you how I close it up because it's more important to make sure that you close it up properly and don't have any screws lying around. So basically, I open up the condensation module at the back, and I found out that these air conditioners are probably made for atmospheres that don't have any high condensation, like in Singapore, in India, southern India, in Goa, and it's a bit of an issue because they create these air conditionings only for certain kind of countries. It has the average room temperature between 22 and 26 degrees. Well, we have an average room temperature of 29 to 32 degrees. The lowest temperature is about 16. The noise level is pretty decent. You can sleep through it. And about 150 square feet, which is not that big actually. If you have a high ceiling in a small room, then you have problems. But at least it cools it down to a certain level, where it makes sense for you to buy something small. So they just cool it down, and you don't have any issues. So it has the louver on top, right? And what I did was basically then I opened it up from the back, a couple of easy screws, and that's your condensation outlet. So this gets cold from the compressor, right? That's your other incoming from the compressor. You have the hot air blower that comes out, right? That's the motor for the hot air blowing. And then you have the evaporator. Sorry, that's the evaporator. Then you have the evaporator tray that's there. And then you have the compressor, which goes and heats this up, compresses it up. And then it cools this, which has a fan on the internal side. And then you blows the cold air out. What we have here is the water comes out, but all this gets wet, right? And I found out that this is the only way, or the only tray that actually keeps the water in. So what I did was, so it comes in there. It's not even that much. It's not even a finger deep. It fills up to the brim, and then it flows over here. It fills up this whole tray, and it goes into this hole, which then drips down from a small little hole in there, which I opened up, that one, and then it goes into the heating element, which actually stops the water from fully condensing. And this is the tray, and then it comes out from here. This is pretty hot during operations. So what happens is it actually should heat up the water and stop that water condensation from coming out in normal circumstances, because in certain countries you don't even have this thing. You actually seal it up, and here this whole tray fills up, and the heat element from this evaporates the water. But it doesn't happen in climates like this, where the humidity is over some people say over 9,000%. It's actually 95% of humidity. Then I realized when this tray gets full, there was a screw that was blocking this, and there's nothing holding up the screw to. There's nothing. So I used a file, removed the screw, and made that hole bigger. So this, in turn, drips right from there onto these grills. And by the time it reaches that, the water evaporates. Right? This second screw goes all the way down this area into the holding tray, which then releases the water out. So I unblock this, open it up. I filed a drainage system here, and now it seems to be working pretty well. I don't know why they designed this kind of evaporator trays that have absolutely no holding power. It's not even a cup. It's not even, it's that deep. It's a pretty good air conditioner, actually, a portable air conditioner. But yeah, let me put it up and let me see how it works.